Let's practice finding all 6 trigonometric ratios together. Keep in mind that for each of these practice problems, theta, or each of these angles, are going to be acute angles of a right triangle, and we're going to go ahead and see if we can find the values for the other 5 trigonometric ratios, or the functions, since we're just given one in each problem. Alright, just to get started, let's go ahead and just lay out what our 6 trigonometric ratios or functions are. We have sine of theta first, then we have cosine of theta, and then we have tangent of theta. So those are our main 3, right? And then each of those 3 have a reciprocal. So the reciprocal for sine is going to be cosecant. I'm going to put that one right next to it. So we have cosecant of theta. The reciprocal function for cosine of theta is going to be secant of theta. And then finally, the reciprocal for tangent of theta is going to be cotangent of theta. I'm just going to go ahead and save this for later. So there are 6 of these trig ratios we're looking for, but we're given one of them already from the start, which is 5/6. So let's go ahead and say that sine of theta is equal to 5/6. And remember that sine and cosecant are reciprocal functions, so that means that the ratio for cosecant is going to be 6:5. Now that we have 2 out of the 6, let's see if we can find out the other 4. At this point, it's helpful to know how to figure out the other ratios. So you may have heard of SOHCAHTOA, where we have sine is the opposite side to the hypotenuse side, that's the ratio. Cosine is going to be adjacent to hypotenuse, or we also know that tangent is going to be opposite to adjacent, right? And another way that's helpful that I think is good to know is sine being the ratio of y to r, cosine being the ratio of x to r, and tangent being the ratio of y to x. So you can think about this as Sierra-Cassirer-Tix. So whether you use the Sierra-Cassirer-Tix or SOHCAHTOA to help you remember each of the trig ratios, make sure you know at least one of them to help you get started with these problems. Alrighty, so let's make a quick sketch together here. So this right here will be our x-axis, and then this can be our y-axis. So we know the opposite side, or the y value, is going to equal 5. So if we go over to this sketch here, we can go say that this is going to be 5. And we know that the hypotenuse, or the r value, is going to equal 6, right? So the hypotenuse, or the r value, is going to equal 6. So then we go ahead and complete this triangle, right? So this last side, we can either call it x, or you can call it the adjacent side. Whatever one you want to use is perfectly fine. I'm going to use x though. Okay, so we have theta located right over here. And so since this is a right triangle, what we can do is use Pythagorean theorem to figure out what that x value is, or the adjacent side, whatever you want to think about it as, okay? So what I'll do here is, let's go ahead and say that x squared plus the 5 squared is going to equal that 6 squared, okay? That's going to be a squared plus b squared equals c squared. X squared plus 5 squared is 25, and then 6 squared is 36. Okay, taking away 25 from both sides, we can say that x squared is going to equal 11. And then if we take the square root from both sides, we can say that x is going to equal the square root of 11. All right, so we just figured out that this x value is going to be the square root of 11. That's the adjacent side to theta if you want to use the SOHCAHTOA acronym instead of using the Sierra-Cassirer-Tix. That's perfectly fine. So this adjacent side and x are going to match what we just found right here. So this x we just found out is a square root of 11. That's going to be the adjacent side to theta, or the x value, whatever you want to think about it as. All right, next for cosine. Cosine is going to be the adjacent over hypotenuse, or the x value over the r value. Now we know that the x value here is the square root of 11, and we know the r value is going to be 6. So what we're going to have here is going to be the square root of 11 over 6. Okay, now if you want to find out what secant is, that's going to be the reciprocal. So if we take the reciprocal of this root 11 over 6, notice what we're going to get here. So that's going to give us, if we find the reciprocal, that's going to be 6 over the square root of 11, but then we have to rationalize that denominator, right? So we can do that by multiplying by root 11 over root 11. And if we do that, we're going to get 6 root 11 over 11. So that's what the secant of theta ratio is going to be. It's the reciprocal, but just make sure that you rationalize the denominator. Finally, we have tangent of theta. Now tangent is going to be this opposite over adjacent, or the y value over the x value, okay? So the y value we have here is going to be 5, and the x value here is going to be the square root of 11. So tangent of theta is going to be 5 over root 11. I'm going to go ahead and write that down here, just because I know that we're going to have to rationalize it, okay? So we can go ahead and multiply this by root 11 over root 11. And if we do that, then we're going to get 5 root 11 on top, and then root 11 times root 11 is just 11 on bottom. Okay, so tangent of theta here is going to be 5 root 11 over 11. And then if that's what tangent's equal to, then cotangent is the reciprocal, right? So if we just go ahead and flip this ratio upside down, that one we don't have to rationalize, that's going to be root 11 over 5. All right, here is number 2. For number 2, we have cosine of theta is equal to 5/8. So we'll go ahead and just write that in for cosine of theta. That's one of them that we're given. And then if we have 5/8 for cosine of theta, then secant of theta is the reciprocal. So this one's nice. We can just write 8 over 5. Okay, now remember that cosine of theta is going to be adjacent over hypotenuse, or x over r. So we have the horizontal side on top. That's going to be x over here. Right? X is going to be 5, and then the diagonal is going to be 8, or the hypotenuse of the circle, whatever you want to think about it as, hypotenuse of the triangle or the radius of the circle. Okay, so first of all, I'm going to go ahead and put this 5 down. It's going to be coming out maybe something like this. Go ahead and put 5, okay? And then our hypotenuse or the radius would look something like this. And then we can go ahead and draw the last side here. So 8 would be the hypotenuse or the radius of the circle. And then here's theta. And what we're missing here is going to be the y value, or the opposite side of theta. So this is the opposite side, and we don't have that right now. All right, so to find sine and tangent, we're going to need this opposite side, or that y value, right? Notice how sine has y in it, and it also has y in the tangent one. So let's go ahead and see if we can find y, and we can use the Pythagorean theorem to help us do that, right? So we're going to go ahead and say that 5 squared plus y squared, and that's going to equal that 8 squared, okay? 5 squared is 25, and then y squared will stay the same. 8 squared is 64. Okay, now if we go ahead and take away 25 from both sides, we can say that y squared is going to be equal to 39. Okay, and then if we go ahead and take the square root of both sides, then y is just going to be root 39. Okay, now root 39 is a radical that can't be simplified, so we're just going to leave it at that. Okay, so if we go ahead and take a look at sine of theta, right, sine is going to be the opposite over hypotenuse, or y over r. So here we have y, which we now know, let's go ahead and label that. Y is equal to root 39. So if we go ahead and say that's y over r, again, this is the r value, or the hypotenuse. So it's going to be root 39 over 8. Let's go ahead and put that root 39 on top of 8. And then if we want to go ahead and find cosecant, that's the reciprocal. So for that one, we're going to have to write that's going to be 8 over root 39. And we can go ahead and rationalize that denominator by multiplying this by root 39 over root 39. And if we do that, then on top, we're going to have 8 root 39. And on bottom, we're just going to have a normal or regular 39 here. Okay, so for cosecant, we're going to have 8 root 39 over 39. Alrighty, then moving on to tangent. Tangent's ratio is what? It's opposite over adjacent, or y over x. So here is our y value, which is root 39, and here's our x value going left to right, which is 5. Okay, so we're going to go ahead and write root 39 over 5. Now, what about for cotangent? Well, cotangent is going to be the reciprocal, so we're going to have to write that's going to be 5 over root 39. And then we can rationalize this by multiplying by root 39 over root 39. And if we do that, we're going to get 5 root 39 over 39. Okay, so our cotangent of theta ratio is going to be 5 root 39 over 39. All right, here is number 3. For number 3, we can see here that tangent of theta is equal to 7 over 3. So let's go ahead and fill that in. That's going to be 7 over 3, and then cotangent must be the reciprocal. So that's going to be 3 over 7. Okay, now tangent's ratio is opposite over adjacent, or y over x. So we're not given the hypotenuse or the diagonal. We're just given a left and right and an up and down. Okay, now this first one I'm going to plot here is going to be this x, or the adjacent side. That's going to be 3, which is a little bit easier for me to plot. So I'll go over 3 units this way to the right. And then our y value is vertical distance, so that's going to be going up 7. So maybe something like this. Okay, now if we go ahead and complete this triangle, we can see here that we are missing this last side, so we can call this r, or we can call it the hypotenuse, whatever one you prefer to call it. I'm going to use r so we can think about that unit circle. Okay, so we don't know the radius here or the hypotenuse of the triangle, but we can figure that out so that we can do our sine and cosine trig ratios. Okay, so for using the Pythagorean theorem, we can say here that 3 squared plus 7 squared, that's going to equal r squared. 3 squared is 9, and then 7 squared is 49. So 9 plus 49 is going to equal r squared. 9 plus 49 should be 58, and 58 is equal to r squared. If we take the square root of both sides, r would equal the square root of 58. Okay, now the root 58 can't be simplified. That is a radical that is at its simplest form, so this is going to be root 58. That's what r is. Okay, now let's go ahead and try sine. Well, sine is going to be opposite over adjacent, or y over r. So our y value is 7, and our r value is root 58. Okay, so for our sine ratio, we have 7 over root 58. And while that's going to be the sine one and we have to rationalize it, why don't we just flip it upside down right now to find our cosecant theta, which is just going to be root 58 over 7. Okay, now let's go ahead and actually rationalize this denominator. Multiply this by root 58 over root 58. And on top, we're going to get 7 root 58. And on the bottom, we're just going to get a 58. Okay, so our sine ratio looks a little messier because we had to rationalize, but that's fine. We have 7 root 58 over 58. Okay, now what about cosine? Cosine is going to be the adjacent over hypotenuse, or x over r. Well, here's x and then here's r, so it's going to be 3 over root 58. Now I'm going to write this over here, 3 over root 58. All right, that's going to be for cosine, which we'll rationalize in just a moment. But secant, let's go ahead and flip it upside down right now. So it's going to be root 58 over 3. Okay, so secant is done now, but let's go ahead and rationalize the denominator for cosine. So let's multiply by root 58 over root 58. So on the top, we're going to get 3 root 58, and on the bottom, we're just going to get 58. So cosine of theta here is going to be 3 root 58 over 58. Sorry, I forgot to write it earlier, but this is where theta is, in case you were wondering. Okay, let's move on to number 4. For number 4, we're given that cosecant of theta is equal to the ratio of 10 to 7. So I'm going to go ahead and write that as 10 to 7 right away, which means we know sine of theta is going to be the ratio of 7 to 10. Okay, now let's go ahead and see where we can draw this triangle and how to draw it. But remember, sine is opposite over hypotenuse, or y over r. Okay, so basically the 7 is telling us how tall this triangle is, and then this 10 is telling you the radius or the hypotenuse, however you want to think about it. Okay, so I'm going to go ahead and write that we're going to get a 7. I'll go maybe up and down, maybe this much roughly. This will be 7. Okay, that's going to be the y value. And then if we go ahead and draw a line straight to the origin, that'll be 10, because that's going to be the r value. So we're going to be looking for this x value, which is the horizontal distance, or the adjacent side to theta. All right, so using Pythagorean's theorem, let's figure out what x is. We have x squared plus 7 squared. That's going to equal 10 squared. Okay, and then x squared plus 7 squared is 49, and then 10 squared is 100. And we can take away 49 from both sides and say that x squared is equal to 51, and then take the square root of both sides. X is going to be root 51, which doesn't have any perfect squares inside, so it's fully simplified as a radical. Okay, so we now know that this x value here is going to be root 51. I'm going to go ahead and just label that, and let's see if we can figure out our other trig ratios. Okay, so let's use cosine now. Cosine is adjacent over hypotenuse, or x over r. Well, this is x, and then this is r. So we're just going to get root 51 on top of 10, right? That would be the cosine ratio. Now for secant, let's flip that upside down. So if we flip it upside down, we're going to get 10 over the square root of 51. And then to rationalize this, let's multiply by root 51 over root 51. And if we do that, we're going to get 10 root 51 on top of 51. So that's going to be what secant of theta is equal to, 10 root 51 over 51. And then we can move on to trying tangent. So for tangent, that's going to be opposite over adjacent, or y over x. So here's our y value, and then here's our x value. So it's going to be 7 over root 51. Now again, this one has an irrational denominator, so I'm going to write it down here first. So while this 7 over root 51 is the tangent ratio, if we flip it upside down right now to find cotangent, that'll save some time later, hopefully. So that'll be root 51 over 7. Okay, now back to tangent, let's go ahead and rationalize this denominator. Let's multiply this by root 51 over root 51. And if we do that, we're going to get 7 root 51 on top of 51. So our ratio for tangent is going to be 7 root 51 over 51. Here's number 5. For number 5, we're told that secant of theta is equal to 12 to 5. So we're going to go ahead and fill that in over here for secant of theta. If we know that, then cosine must be the reciprocal. So that's going to be 5 to 12 for its ratio. Okay, now let's use this information. Let's use cosine of theta is equal to 5/12. And let's go ahead and use this ratio here. So again, that's going to be, this 5 is going to be the horizontal distance, and then 12 is going to be the radius of the circle. And so that's going to be the hypotenuse also, or the diagonal. Okay, so for cosine, we have an x value. So I'm going to go ahead and move left to right here. That's going to be 5 units over here. Okay, and then we now know that this 12 also is the radius or the hypotenuse, so that's got to be on a diagonal. So let's go ahead and draw something, maybe something like this, something a lot longer. That'll be 12. All right, so we have two sides of our triangle, and then we can go ahead and just draw our last side over here. This will be our y value, or you can call that the opposite side of theta. That's fine as well. And so let's see if we can go ahead and find out what y is, or the opposite side, so we can figure out the other ratios. Okay, so we can go ahead and say that we have 5 squared plus y squared is equal to 12 squared. 5 squared is 25, y squared is going to stay the same, and then 12 squared is going to be 144. Okay, if we take away 25 from both sides, we're going to get y squared is equal to 119, and if we take the square root from both sides, we're going to get y is equal to root 119. Now you should check to see if we can simplify that radical, but I don't think we can, so we're going to leave this as root 119, and that's going to be the y value, or the opposite side for theta. Okay, now let's go ahead and do sine. Sine is going to be opposite over hypotenuse, or y over r. Now here's y and here's r, so that's going to be root 119 over 12. Okay, that's going to be the sine. And then for cosecant over here, let's flip that upside down, and then we're going to have to rationalize the denominator. So we'll have 12 over root 119. If we rationalize this, let's multiply this by root 119 over root 119. And when we do that, we get 12 root 119 over 119. Okay, so we can write 12 root 119 over 119. Okay, finally we have tangent for this one. Tangent is going to be opposite over adjacent, or y over x. Here's y and here's x. So when we go ahead and write that, it's going to be root 119 over 5. Now for cotangent, let's make sure we flip that upside down to find the reciprocal. So that's going to be 5 over the square root of 119. And then we can rationalize this just like we did earlier, multiply by root 119 over itself. When we do that, we're just going to get 5 times the square root of 119 over 119. Go ahead and write that in here. And now we have all 6 trig ratios. All right, here's one more. For number 6, we have cotangent of theta is equal to the ratio of 6 to 11. All right, so cotangent is 6 over 11, so we can go ahead and write that in where cotangent is. And then if we know cotangent, then tangent should be the reciprocal, so that's going to be 11 over 6, or the ratio of 11 to 6. Now, if we know that tangent of theta is 11 to 6, which also tangent is opposite over adjacent, or y to x, then the vertical distance we have here is going to be 11, and the horizontal distance is going to be 6. So I'm going to go ahead and draw the horizontal distance first. So 6 is going to go this way, and then the vertical distance is going to be 11, so maybe something like this. And then we don't know the hypotenuse, or the radius of the circle, so we'll keep that as r for now. It's a right triangle, and here's theta. And now let's see if we can go ahead and figure out what r is, right? So that we can actually find our sine and cosine ratios, which require the hypotenuse or the radius. So we can go ahead and say here that 6 squared plus 11 squared is going to equal r squared. 6 squared is 36, and 11 squared is 121. Add those together to get r squared. 36 plus 121 is going to be 157, and that's equal to r squared. And then we take the square root of both sides, r will equal the square root of 157. Now I don't think that can be simplified, so we know r is equal to root 157. So let's go ahead and figure out what our sine and cosine ratios, as well as cosecant and secant. Okay, now for sine, that's going to be opposite over hypotenuse, or y over r. So here's y and here's r. So I'm going to go ahead and write that as 11 over root 157. I'm going to put it down here because we know we have to rationalize this. Now we can just do cosecant real quick, which we're going to just reciprocate it. So that's going to be root 157 over 11. Okay, now let's just go ahead and rationalize this to get the sine ratio. So when we do that, our sine of theta ratio is going to be 11 root 157 over 157. Now finally, for cosine of theta, that's going to be adjacent over hypotenuse, or x over r. So here's x and here's r. So we can go ahead and write the ratio as 6 over root 157. Okay, we'll rationalize that in just a moment, but for secant, that's going to be the reciprocal. So we can go ahead and write that's going to be root 157 over 6. And then let's just go ahead and rationalize this denominator so we can write our cosine ratio. So cosine of theta's ratio is going to be 6 root 157 over 157. All right, so there you have 6 different practice problems on being given one of these trig ratios and then finding out the other 5. In these ones, I wanted to make sure that we couldn't simplify any of the radicals, so we didn't have to think about that. But in some other practice problems, you may have to simplify the radical and pull out perfect squares as well. So hopefully you found this video helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.